Welcome to this series in which we're going to learn how to solve quadratic equations using factorization. And this goal may already raise some questions in your mind. What are quadratic equations? What is factorization? And why are we interested in this? So in this introduction, I want to show you what we're going to work towards, and I'll give you a brief overview of the steps we're going to take to get there. And then in the next videos, we'll go into these steps in more detail. If you're watching this video, you've probably encountered equations before. And for now, you can think of them as calculations that are missing a number. And our task is to find a number, or perhaps multiple numbers, that fit. For example, in the equation 5 plus x equals 9, there is only one value for x that works. If x equals 4, then we get 5 plus 4 is 9, and that is correct. And we also have a procedure for finding this number. By removing 5 here and removing 5 here, we are left with just x on the one side, on the left side, and 4 on the right side, and then we're done. And this is an example of a so-called linear equation, which means that both sides of the equation are formulas for lines, and those are usually easy to solve. In this series, however, we will focus on quadratic equations. And that means that at some point we will be taking the square of the missing value. This one, for instance, x squared plus 15 equals 8 times x. So what number can we choose so that this is correct? Well, actually, in this case, there are two solutions. The first solution is that we replace x by the number 3. And we can check that this works, because if we change this x into 3 and the other one into 3, then we get 3 squared plus 15 is 8 times 3. Is that true? Well, 3 squared is 9, 8 times 3 is 24, so this says 9 plus 15 is 24, and that is correct. So we can replace x by 3. There is another solution, however, which is x equals 5. If we replace x by 5, then we get 5 squared plus 15 equals 8 times 5. And that's just saying 25 plus 15 equals 40, which is also right. So we can see that these solutions to the equation are correct. Checking them is easy, but finding them is more complicated, right? So how are we supposed to find the correct values for x? And that problem of finding the correct values is the problem of solving a quadratic equation. And that requires multiple steps, and this series will guide you through those steps. So in order to give you a sense of what we are going to do, here is a very brief outline of the basic idea, and then detailed explanation will follow in the next videos. So suppose we have a quadratic equation like the one we just saw, x squared plus 15 equals 8 times x. The first step is to remove every term on one side so that one side becomes 0. So in this case, we can subtract 8x from both sides, and then the right side becomes 0. And then it looks like this. And the left-hand side is now a sum of 3 terms. We have x squared and plus 15, and also we subtracted 8x. And now we get the weirdest and the cleverest and the most elegant step. The left-hand side, this sum can be rewritten as a product, x minus 3 times x minus 5. And we will spend a lot of time on understanding how this step works. And then the next clever idea is the following. The result of this product is 0, because we decided to write the equation in this way. And that means that at least one of these two factors must itself be 0. So x minus 3 must be 0, or x minus 5 has to be 0. And both of these cases give us an easy linear equation. If x minus 3 is 0, well, then what does x need to be? Then x is 3. And if x minus 5 is 0, then x equals 5. So the crucial trick here is to understand how factorization works, and that's where we will start. So in this series, we will first look at factorizing numbers, and then at factorizing formulas, and then finally at factorizing quadratic formulas with 3 terms, which is the most difficult case. And we will do that using a method based on the idea of finding 2 numbers with a given sum and product, so-called sum product method. And then we will put this factorization to use to solve equations by this rule, which we'll look into later. And finally then, once we have used this rule to solve equations, we'll look at some applications of this strong tool that we've just developed. In each of these steps, you'll get some instruction on the basic principles first, then a few complete examples, and then some sample exercises to see if you understand the procedure so far. And sometimes you may want to skip some of the examples and move straight to the exercises, and sometimes you may want to study the examples carefully before moving on. That is up to you. So let's get started with factorization.